Welcome to today's explainer. Okay, let's just dive right into this, because today we are unpacking something that is literally changing the entire landscape of technology, automated machine learning, or AutoML. Our goal today is super simple. We're going to look at how we can unlock the incredible power of machine learning for everyone, not just the expert coders or the highly specialized data scientists. If you've ever felt like machine learning was locked behind this impenetrable wall of complex code, well, you're in the right place.
Here is our roadmap for today. We'll start with the machine learning bottleneck, look at the sheer power of AutoML, weigh the trade-offs and limitations, figure out how to choose the right path for your team, and wrap it all up with a complete no-code AutoML workflow. Section 1, the machine learning bottleneck. To really get why AutoML is such a massive breakthrough, we've got to look at the notoriously difficult, insanely repetitive manual workflow that it's designed to fix. Just look at the stark contrast here. On one side, you have traditional manual ML. This traps you in this endless web of complex coding, iterative tuning, and experiments that require some seriously specialized skills. But then you have AutoML. It completely flips the script. It automates all those repetitive tasks, democratizes access, and just blasts right past those coding hurdles so you can focus on what actually matters, your data. Let's actually break down what those manual tasks look like. In a traditional setup, you're doing manual feature engineering. You have to figure out exactly which ML algorithm to use out of dozens of options. You're manually tweaking hyperparameters, which are basically these hidden little dials and knobs that control how the algorithm learns. Then you write custom training code and evaluate metrics across multiple testing datasets. Now, could a highly motivated expert with endless time do all this? Sure, absolutely. But for teams without a dedicated data scientist on staff, this is a massive bottleneck. It makes trying out machine learning basically impossible for smaller or exploratory projects. Which brings us to Section 2, the power of AutoML. Let's look at how automation fundamentally shifts this entire landscape and solves those massive bottlenecks. So what actually is it? Well, AutoML is essentially a powerful set of tools and tech that completely takes over the heavy lifting. We're talking about automating the repetitive data engineering, the training, and the analysis tasks in your machine learning workflow. By putting the model development cycle on autopilot, things like feature selection, tweaking those hidden dials, picking algorithms, AutoML makes building models so much faster and way more accessible. And here is the absolute crucial point you need to take away from this. AutoML democratizes machine learning. Because you're automating all those heavy ML tasks, you no longer need this deep, highly specialized understanding of complex algorithms just to get a functional model up and running. No specialized programming required. You finally get to focus entirely on your core problem and the data you're feeding into the system. Moving on to Section 3, trade-offs and limitations. Look, as much as AutoML sounds like pure magic right now, we do need a quick reality check on its real-world limitations before you go deploying it everywhere. Let's weigh the pros and cons fairly here. On the benefit side, AutoML saves a massive amount of time. It completely bypasses all that manual experimentation. Plus, it acts as an incredible smoke test for your datasets. Think about it. Even if you're an expert, AutoML can quickly tell you if your data actually has enough baseline signal in the noise. Like, if an AutoML system can't even build a mediocre model with your data, it's probably not worth your time to try building one from scratch by hand. It also bakes in ML best practices right out of the box. But the trade-offs are definitely real. The way it searches for models is pretty opaque, making it tough to understand the complexity. Multiple runs can show significant variance, so you might end up with different results. Also, the absolute peak model quality might trail behind what a human expert could custom build, and you get zero customization during the actual training process. It's a black box in that regard. All right, Section 4, choosing the right path. With all that in mind, how do you actually decide which approach makes sense for your team right now? It really boils down to self-identifying what you need most. You should lean towards AML if your team has limited ML experience, or honestly, if you're an experienced team that just wants massive productivity gains and doesn't need deep mid-training customization. On the flip side, you're going to want to stick to custom manual training when absolute maximum prediction quality is the priority. If architectural customization is paramount to your project's success, you've got to do it by hand. It takes way more time, but the ultimate ceiling for quality is higher. Now, I want to highlight a really surprising fact about data requirements here. Usually, whether you're doing custom ML or AutoML, you need a massive amount of data, like a ton. But there is an exception. Specialized AutoML systems use this incredible technique called transfer learning.
So instead of needing hundreds of thousands of examples to build, say, an image classification model, these systems build on existing frameworks. That means you might only need a few hundred labeled images to get an incredibly effective model. It is a total game changer if you're constrained by data.
Section 5. The no-code AutoML workflow. Let's get actionable and look at exactly how you can start using these web-based tools today.
Because AutoModel is taking care of the architecture and searching for those hyperparameters for you, your burden shifts almost entirely to obsessing over your data quality. I cannot stress this enough. Before you import a single thing, you have to prep your data. First, label it. Every single example needs a target label. Second, clean and format it. Real-world data is notoriously messy, and you have to resolve those issues up front. Third, think about feature transformations. Now, some tools do this for you, but if you have really complex relationships in your data, you might need to pre-calculate those to get the best possible training results.
Okay, so your data is prepped. From here, the no-code interface workflow is beautifully intuitive. Step 1. Import your data source. The system will automatically try to assign semantic types to your values here. Step 2. Analyze the data set pre-training. Use the built-in tools to really understand what you're working with. Step 3, and this is vital, refine the data. Do semantic checking. For instance, make sure your postal codes are actually recognized as categorical data, not continuous numeric data. That'll mess everything up. And finally, step 4, configure your run parameters.
This is that last little bit of human input before the machine takes the wheel. You'll select your ML problem type, so are we doing classification or regression? You'll designate exactly which column in your spreadsheet is the label. You'll pick the specific features to include and maybe limit the ML algorithms you want the system to bother searching through. Then you choose the evaluation metric the system will use to decide which model is actually the best. And that's it. You hit start, let it train for a few hours, and you're golden. Which leaves us with this final provocative thought. By drastically lowering the barrier to entry, AutoML shifts our focus away from writing complex algorithms and pushes us towards exploring the quality and the creativity of our own data. It empowers you to solve real problems without getting bogged down in code. So, if the system can handle the math and the architecture, what incredible data will you bring to the table to build something amazing? Thank you so much for joining me for this explainer, and happy building.